Hi, folks. I'm Brian Kane, and welcome back to the pole barn of bad decisions, broken dreams, where the coffee's always hot. Nope, not so much. It's kind of like life, sometimes disappointing and lukewarm. But we're going to move on. We're going to do a little work today. We've got some wiring going on today, and we've got all of our things laid out here that we're going to be needing to work on the 1966 Chevy Nova. We've got an original wiring diagram here. Show you a picture of that in a second. We've got our list of things that need to be taken care of. Got some parts here that we're going to be installing, and we've got our painless wiring diagram and our repair manual here so we can look up things. We've also got an extra relay here that I'm going to show you. There's a couple of different kinds of relays. We're using a 4-pin relay panel on the 66 Nova today. And what we're going to be doing is we're going to be wiring up some components that need a little bit higher amperage than the standard wiring probably should handle. So I got these relay panels here off the Jungle website, and we're going to install those. They're pre-wired. We've got this one here has 8 circuits with 2 relays, and this one has 4 relays with 12 circuits. And I think we're going to be using this one because the things that we're going to be wiring up that need higher amperage is going to be our fog lights. We're going to go ahead and wire in our headlights to those relays. We have to have fans for the cooling system because we're going to be putting on an electric fan system. We've also got an air conditioner that eventually is going to be installed, and we need to wire that up as well. So that'll be controlled by a relay as well. So we'll get you in the car, show you what we're doing. We've got a couple of problems. The car 12-volt system uses a ground on the original horn relay. And that's another item that we're going to be using on our relay boards is controlling the horns that we're installing. And the old horn relay was ground controlled. Now we've got both of our relay boards here, and they are positive controlled, which isn't a tough thing to change. Not a big deal. It just gets wired up a little bit differently. And the other problem is that, we've got some wires that we just don't understand. We're going to have to look into it. And I'm not bad at 12-volt wiring, but I'm definitely not a professional. So we're going to need to figure out how to wire these things up correctly, get those circuits protected, and get it installed. Sit back, relax, grab yourself a cup of coffee, and enjoy the video. Thank you. So we've got our wiring system diagram here, and you can see our horn relays here, and it is ground controlled on this black wire right here, which goes up over here, down, and into the steering column right here. So what we need to do is we need to trace these wires out on the painless wiring diagram or the painless wiring system and try and figure out where we need to hook up the correct wires. I want to take you through the 4-pin relay that we're going to be using and how to wire that up in our system. And I'll bring you in and give you a close-up here of the 4-pin relay wiring that I've drawn out, and we'll explain how it works, what needs to be done, and how to make it safe. I've tried to simplify this to help some of the people that aren't real strong in their electrical knowledge. So what we've got here is our small circuit pattern here. We have our battery, we have our fuse block, we've got an ignition switch, we have our fan, of course we have our relay, and we have a temperature sender. Here is the relay box, similar to the one that we're using. And normally, what would happen in this relay is we've got pin 85 and pin 86. Pin 86 would normally be grounded directly. Pin 85 would get a, I think as small as a 400 milliamp power source draw through the ignition switch. There is a set of small contacts here in our relay, and when pin 85 and pin 86 circuit is closed, what happens to these contacts is they close. So we've got power coming from our battery through our 40 amp protected wire into the 30, out of the 87, and into our component of some sort. Now, in our fan relay wiring diagram, the source for ground comes through the temperature sender. At 180 degrees, this sender is going to complete a circuit between the engine ground, common ground, and our battery here is going to a common ground. Cable comes out, goes to the engine block or the body or wherever, common ground. And when at 180 degrees, it's going to close this small circuit here and provide ground to pin 86. So when our engine heats up, we're going to have ground coming from the temperature sender going through 86. We'll have a constant source of voltage on pin 85. And when that circuit is complete, it's going to close the contacts here in the relay, and we're going to get power through our protected wire to the 30 pin, coming out of the 87 pin and going to our fan. So, in conclusion, when we get 180 degrees, closes the contacts, lights the fan up. So here we have our relay box. And what we have here is we have our 2 relays in this box with 6 fuses. So what we've got here is we'll start with power coming out of the relay. When the circuit is complete, power comes out of the 2 yellows here to control whatever component you need to control. We have our constant wires for power going into the relay. So when connection is made, power is going in from the battery and basically out through the yellows. We have our common ground here, which provides a ground to the contacts on both relays. On the 2 white wires, we have our trigger. We're going to control these relays from this trigger or this ground. And then we have 4 wires here for 4 of the fuses that are on the front side of this. So what's going to happen, or what normally would happen, is you've got a common ground. That's going to go to a straight ground. You've got your 2 white wires, which are your triggers. You provide power to the triggers. That's the a minimum of 400 milliamps of power that's going to close the contacts in the 2 relays. You've got your constant power coming in. Once those contacts are closed, that completes the circuit. You've got power coming out to your component. Now, you've got 2 trigger wires. So these 4-pin relays can be triggered either by ground or by power. So if you provide that 400 minimum of 400 milliamps to these two wires all the time and then switch the ground, that's going to activate both of the contact points in the two relays, and you'll get power out to two items. If you were to provide a constant ground and then somehow switched the minimum 400 milliamps of power to activate the contacts, you could do it individually and do one at a time. In our case, we needed one relay to control one fan. The relay boards that were purchased have one common ground. So we went inside and the ground wire is right here, comes in here, daisy chains over to the second one. We cut that wire and we put an additional wire in this relay. So both of these relays had their own ground. And when we needed our fan activated at 180 degrees, it gets its ground through the temperature sender at 180 degrees and activates the relay. So at this point, this is the mess that we have right at the moment. And once everything is wired up correctly and is working correctly, we're going to get in there and we're going to organize all of these wires and make that look nice and professional. But we have to make sure that everything is working properly before we do that. Otherwise, we're just taking things apart, putting them back together, taking them apart, putting them back together. We have installed some nutzerts into our fender well here. There's one right there, right in the center. There's another one right there that our common grounds are going to. And we have two that are installed that we're going to be using to hold the relay box down. So once that is all taken care of and we have this wired up correctly, we'll get you in there and show you what we've done to organize and make these wires look nice in the engine bay. Hi, folks, and welcome back to the pole barn of bad decisions and broken dreams, where the coffee's always hot. Not so much. But we're going to continue on. We're going to drink our lukewarm coffee or our brake fluid and get you in on the 1966 Chevy Nova. We are working on wiring up relays. There's going to be a lot of information on this video about wiring relays, modifying relays, and getting them installed to control components, either with a ground circuit or a powered circuit. So sit back, relax, grab yourself a cup of brake fluid, and enjoy the video. Here you can see the wires spread out on our relay box, and you can see our common ground coming in and daisy chaining over to both of those relays. This is the wire that connects the two that we cut and ran a new ground wire out to control just one of the relays with a ground circuit. Hi folks, we're back on the 1966 Chevy Nova working on the wiring system. We have our relay box here that we have modified. We're going to get you inside, show you what we've been doing in here, and show you how we've modified the relay box for our fan setup, which is a ground triggered setup as opposed to a positive wire trigger. Here we have our relay box. And you can see that we have our power wires coming in from the battery. We've got, for our fuses on the back side, that's all of these fuses right here. We've got our power wires that are blue coming out. We have our yellow wires for all of the relays, and that's power coming out of the relays. And we have our trigger wires that we've installed WeatherPack or Deutsch connectors on them to seal those up. Now we have our common ground here in the relay box, which comes in and daisy chains to the 4 relays here, 4, 3, 2, 1, and we're going to use relay number 1 for our fan setup. Now the fans are triggered by a ground circuit that goes through a temperature sender. So what we needed to do is we needed to take the common ground off of the number 1 relay and change that to its own ground. We've got our common ground here, comes into here, and originally it daisy chained into 4, 3, 2, and 1. So we went in, we removed the wire, we cut one of the wires going to the number 1 relay, and then we ran a new wire out the side, which is going to go to our 180-degree temperature sender. So once the engine reaches 180 degrees, it's going to complete the circuit in the relay and kick the fans on. So what I'm thinking about is using this location right here to install that 4-pin relay. You know, the nice thing about it is we can put some tabs on here through our riv nuts, and we can fix up this wiring harness and make that look nice coming over here. So that's my thought on the installation, and I think we're going to go from there and see how that works. We've got a hole already here that we can go to, and our wires come out the bottom, so we can connect all of our wires and we can go around to the battery or around the front to any of our components. So on these electrical connections that we're putting on the wiring, these are the connections that the painless wiring system comes with. And I don't like these giant insulators that come on the connectors. I like the insulator-less connectors. So what I'm going to do is I'm going to pull that off, and we just take a couple of needle nose pliers. We're going to hold on to it, and they come off pretty easily. All you got to do is give it a little twist, and that will slide right off. Then what we can do is we can crimp that on the wire and use our shrink wrap and make that installation look a whole lot cleaner. So, like I said, we're back working on the 1966 Chevy Nova, and we're going to start focusing a little bit more on getting this engine broke in. We've been doing a lot of wiring. I've got 4 videos out there now with wiring this thing. We do have to do some organizing of some of the wiring. We may do a little bit of that, but we're going to focus a little bit more on mechanical stuff. And I think the next item up for bid is to get our fuel pedal installed in the interior. We need a fuel pedal in the interior to hook up to our carburetor. When that gets installed, what we're going to do is we've got the original little single barrel carburetor that we're going to install on the engine. We're going back to the basics on this engine. We've put all the original equipment back on it, and that's what we're going to be using for the break-in. Now we've got a larger carburetor in the storeroom that we're going to be putting on it, and we've got a different valve cover, we've got a different intake manifold, different exhaust manifolds that are all going on it. But what we're going to do is we're going to break this engine in on the original equipment. Let me get you in here, show you a little bit about what we've got, what we're going to do, and what we've done so far, and where we're headed. Like I said, we've been doing a lot of wiring on the car, and I'm getting a little burnt out with the wiring. I know those wiring videos are not the most exciting videos in the world, but it's something that really has to be done if we're going to start working on, or excuse me, we're going to start driving the Nova on a regular basis once that engine is broken in and we get everything else done. There is a ton of work that still has to be done. We've still got the giant list. You can see that video of everything that has to be done with the interior, the trunk, the engine bay, the transmission, the engine itself. So let me pull you in here, show you a little bit about what's going on in the engine bay and where we're going to head for this video. So as a recap, we've got our relay box that we're installing. And you can see some of the wiring that we're doing. We've had to add some circuit protection that's going to the outputs of our relays. We have just a ton of harnesses that we've built and installed. We've been working on battery cables, getting lugs on those, putting in breakers and fuses for the power to the relay box and our alternator that we installed. We have our intake manifold that we've installed. The original exhaust manifold is there. This is where that single barrel carburetor is going to get put back on for our break-in. We've been working on the brakes. One of the things that I have done is I installed a smaller starter and some fittings so I can have the original light for the dash and a gauge sender installed so we can run an oil pressure gauge and see that. We're going to need to install, there it is right there where the X is. We're going to need to install our distributor and get that. We're going to need to wire that up, get wires so all of that can run. And that's kind of the direction we're going to go with this video. We need to get a fuel system plumbed up so that we can run the vehicle. We're probably going to do something like I don't have it here handy, but we're going to take a can and probably pull fuel out with this electric pump out of a 5-gallon fuel can and provide the fuel for the engine. That way we don't have to put fuel in our fuel system right at the moment and leave it there and have it sitting there while we're doing the rest of the work. So that's how we're going to run fuel for it. So we have to build that fuel can and fuel system, and we'll show you that when we get to that. We have our engine here and we've got our bypass here, and I've been asked what this wire is, and this is actually just solid core wire, and I wrapped that around there in a coil so that this hose wouldn't kink when we made this very sharp bend. So that's the direction we're going in. Now we've got to figure out what the next thing is, and I think in some way, shape, or form, we're going to be working on the gas pedal right now to see if we can get a gas pedal in there and get some of those pieces set up so when we do put on that carburetor, that we can hook something up to that carburetor and control the fuel going into that engine while we're breaking it in. Here we have the original parts for the gas pedal. So we're going to get those installed in there and see how those are working. I've taken these and sanded them down and painted them. I wanted them to look nice. That's part of the OCD problem I have. If I take something off the Nova, it has to be better when it goes back on. It can't be rusty, it can't be ugly, and we want it to look nice when it all goes back together. So I've sanded these all down, all these parts. Here is, this actually goes on the end here and moves back and forth when that pedal is actuated. So we're going to get that installed, put that in, see what we have to do to get some control on our carburetor. Now on to the inside of the car. Take a look at what we've got going on the interior for that gas pedal. And we'll get in here and try and do this so nobody gets sick from all the bouncing around. But here is our underdash. We're going to have to do a little bit of organizing here on these wires. And there's where the bottom of the pedal connects to the floor. And up inside where that rod goes through to actuate that. So we're going to get this all cleaned up a little bit and moved out of the way so we can do some work in here. Here is the location where that fuel pedal assembly is going to be installed, right there. Get that in focus. Ah, that's perfect. And that's where that assembly gets installed, which is this assembly right here. So I'm going to find the bolts that connect this bracket here to the firewall and get that installed. And then this here is the lever that connects to the pedal lever to actuate the carburetor. We're going to run a tap through those holes that hold that bracket to the firewall. We want to chase those threads out, make sure that those threads are nice and clean and they're going to hold tight. And depending on how that works out, we may end up putting a bolt on the other side of that to keep that bracket nice and tight to the firewall. So here is what we've got going on here that looks kind of funky to me. And these are things that come up on any build that you do. I put this nut or screw bolt back in exactly where it came out of. And as you can see, our throttle lever moves. It doesn't touch this, but it seems like that seems to be an extremely long bolt for what it has to hold. So what I'm going to do now is I'm going to pull that bolt out, put something else in its place that is far shorter. It just doesn't look good sticking out of the firewall like that. And that's our next thing that needs to be done. So after trying a few different fasteners, I just opted for a 7/16 nut and bolt to replace that. I'll call it a wood screw. And I have a problem with running wood screw threads through a firewall to hold something down. We'll get you inside and show you the other side of that on the interior of the firewall and show you what that's holding. So here we are on the inside of the vehicle, and there's our brake pedal. There is our gas pedal that we just installed, and this here is the bolt that I replaced. And what that holds in is a bracket for the heater system here. So now that's nice and tight. That's not going to move. We don't have the opportunity for wood threads to loosen up and make squeaks and noises. We've got that nice and tight. We've got the original gas pedal that came with the Nova installed right now, and we're learning things. I wanted to figure out just how much room I had between that gas pedal and the actual steel of the floor, because we've got to put some sound deadening material in, as well as a new carpet that's going to go in the car. So that's a nice thing that we were able to set that there and just take a look at it and make sure that we definitely have enough room to put that carpet and sound deadening material in. As you can see, that original or original to the car when I bought it, gas pedal that came with it, it's seen its better days. It's broken out. It doesn't sit real well on the balls that are on the floor. So we've got a replacement, and we'll put that in the, I guess, final build when we finish everything else. I imagine when sound deadening material goes in, we'll probably have to do a little space around that gas pedal so that we get full travel on the throttle plates in the new carburetor. That'll be definitely something to look out for. But another thing that we learned is that our rod or spoon that sticks in through the firewall is lining up correctly with the gas pedal itself. It's been a few years since was taken apart, so I'm not 100% sure, but I do believe that this is the correct orientation of the rod for the accelerator on the carburetor. We'll have to get the carburetor on there, and there is a bracket that sits on this stud right here, and we'll have to make sure that that is the correct orientation to actuate those throttle plates in that carburetor. I believe that is going to end our video on installing that gas pedal. We've got that installed. Our next video is probably going to entail a little bit more wiring. It's looking like we probably should get some type of a temporary exhaust system put in there so we can route that exhaust either out the side of the car, out the back, just so it's not blowing down straight onto the ground or onto our components down here. So that'll be our next video. I want to thank everybody for stopping in. Appreciate it. So we've been talking about, the installations that we're doing and some of the memory problems, from taking this car apart in 2016. These are things that are going to come up when you take on a long-term build like this. You're going to not remember how things are put together. You're going to use other fasteners, other ways to fasten things when you put things together. I'm not the be-all, end-all for this kind of stuff. I'm just trying to use my common sense, put this car back together, put it back on the road so I can drive it and enjoy it. It doesn't have to be a show-winning car. It doesn't have to be perfect. I can use a grade 5 bolt where a wood screw type fastener was used and not worry about it, because I know that when I put a nut, a bolt, a washer, and a lock washer on something, it's not going to come apart. These are the things that some of you young guys that are getting into this hobby and doing this on import type stuff. You're going to take a car apart and you're going to have all these bags of bolts and stuff and not remember how it came apart, how it went together. I've taken pictures. I have pictures that I can go back and look at from when I first bought the car and look at a few things, but you never end up really getting that perfect picture of what you're trying to put back together. And that's one of the problems with taking pictures of your vehicle when you're taking it apart, because inevitably when you go to put everything back together, you're looking at it, and when you're taking it apart, you're snapping a quick picture, throwing the camera down, blowing it apart, putting it in bags, thinking you're doing everything right. And then years later, when you go back to put it together, you look at that picture and the angle is just a hair off and you don't see exactly what you're looking for. So you have to make guesses and put things together and use your common sense. Just want to take a second and thank everybody for stopping in. If you have a moment, please like and subscribe. And That'll give me the opportunity to make more videos like this, show the 1966 Chevy Nova and our rebuild process of what we're going through to get this rebuild engine in, get it started, get it broken in. I really appreciate you staying until the end. Thank you, and have a good day.